So what's the difference between an array and a list? An array is fixed in length, meaning that once you decide how long it is, it's a huge amount of trouble to make it longer. It's like building an apartment complex in a tightly packed city. Once you build the apartment, you're kind of limited to the number of people who could move in. If you want to add on an extra room to the apartment complex, well, too bad. You'd probably have to tear down the entire complex and then rebuild it in order to support a new one. So a list can expand or contract. So the guy who invented Python, I guess he didn't like the idea of anything being fixed in length, so he only supported lists. And so like I said, I will refer to them interchangeably. The book is always going to call them an array, and it's okay for us to call them lists because that's what they are, the way that we're going to be using them in Python. It's okay to also use them arrays. The only time when it would be bad to call it an array is when I'm showing you something that's not in the book. And why not get that out of the way right now? Let's put something into the array by appending to it. I'm going to pin the number 1, 2, 3, 4, 5 to that empty array. And then I'm going to print it out again. Right? And so now it was 7 elements long. It's now 8 elements long. Right? It's got 8 numbers in its sequence. So the mere fact that we were able to call and append on it means that it's not a strict true array. But the Python version, the list is actually more flexible. So we're good. We're happy to have it. Let's go. And these sure are taking a long time to open. Here we go. So an array is, they call it a series. I called it sequence, whatever. And then they said, or list, like that's a colloquial term for an array. Okay. It's a series or list of variables in computer memory. I don't know if I would say it's a series or list of variables. That makes it sound plural. This is just one variable that contains a series of values, right? This isn't 7 variables. It's one variable that points to 7 values. So I might argue with their definition there a little bit. It's all right. They know what they're talking about, right? All variables share the same name and must share the same data type. Okay, I see why they're calling them variables. If we do this, color array equals red, comma, green, end quote, comma, blue. The book is saying that there are 3 different variables there. And in a way there are, I guess. I can print out CA square brace, not the curly brace, so the parentheses, 0. And then I could print out CA square 1 in square. And I'm going to start calling that subscript. Whenever I say the word subscript, just think of the square braces with a number between them. And then print CA subscript 2. And that's going to print out red, green, and blue. And so it did, right? And so they're saying that this is 3 variables. I can live with that. The textbook says that these all have to be of the same type. Now, Python, being the weird beast that it is, would let you get away with storing different pieces of data in the same array. If we wanted to, we could make an array that looked like this, and it had a number in it, and then it had a string, you know, and then it had a float, and then it had the word false in it, a Boolean value, right? That's okay in Python, but technically speaking, we want our arrays to be values of the same type. So an array is a sequence of values. If I was going, I don't know. I may not try to reword what they're trying to say there. So an array is a sequence of values. Each element in the array has the same type, or at least should. And the book says that they all have the same name, which is what we see here. I just think that it's one name, but where the subscript differentiates it. It's like going back to the apartment example, right? I have an apartment building and it's got 10 people in it, 10 houses in it, 10 apartments in it. I don't say I have 10 apartment buildings. That's the array, right? The apartment building is the array and it's full of apartments and each apartment is the value. Each variable has a different subscript. That's how you access the values of an array. It's also called the index. Index and subscript can be used interchangeably. So an array is a sequence of values. Each element in the array has the same type. Each element is accessed by its subscript, parentheses index. The subscripts, the indexes start with 0. It's like you checked into Hotel 6 and they told you you were in room 0, right? Rather than room 1. Just quirk of computers is that they do zero-based indexing, so they start counting as 0. So that would be element 0 right there. That would be element 1. That would be element 2. That would be index 3. That would be subscript 4, subscript 5, and subscript 6. Here, this is subscript 0. This is subscript 1. And this is subscript 2. I'm never going to use this one again, so I'm just going to delete that one. So an element is the item in the array. This says array elements are contiguous in memory. Well, I'm just going to leave that statement alone. The idea being is that if you declare an array and it's got 7 values, then hopefully in the computer memory, they're all right in a row. The size of the array is the number of elements it will hold. You could also call it the length of the array, kind of interchangeable. What is the length of this array? It's 3. What is the length of this array? 7. Count them out. What is the length of this array? Well, it was 7 here, but then we appended something to it, and so it became 8. So what if we want to print out one of our arrays and not doing it like that? That's kind of tedious, right? If I have this 7-digit phone number here, I don't want to have to print out P in subscript 0, P in subscript 1, and so on. I'd rather use a for loop. So for E, IN, PN, or I could change that to a V. I was using E for element, but V for value works every good. For every V, for every value in the phone number, print that value. And so it's going to print out 8 on one line, 6 on the next, 7 on the next, 5, 3, and 0, and 9. So this is printing the array with a value-based for loop. We've seen for loops before, but we hadn't really seen value-based for loops. We had seen range-based for loops, right? For X in range. And there we go. I printed out our 8675309 right there. And we could do the same thing with our color array. For V in the color array, print V. Just using V as a short, right? An abbreviation for the word value. So for every value in the color array, print that value. And it did. It printed out red, green, and blue. you can change the values of the array by their subscript. Let's say we really don't like the color red. We want to get rid of that color red. We want to paint it some other color. So CA is equal, CA subscript 0. The first in that element in that array is now yellow. Was red, now yellow. So if we print the array before we make the change, and then after we make the change, we will see that the first element changes to that value. Right, and so before the change, it was red, green, and blue, and then we changed element 0, element subscript 0, made it yellow, and so now it says yellow, green, blue. So an array, its value can be used anywhere that a value of that type can be used. So since these are integers, these integers could be used anywhere that an integer is expected. So if I wanted to take something to the power of something else, I could do that. This is just silly, but I have that phone number. I could say that I want to take 3 to the power of element number 5 in the phone number. Right, so whatever that is, I'm going to have to go back up and look to see what element 5 is, but 3 to the power of that one, I could go look. Well, that's element 0. We always start counting at 0. 1, 2, 3, 4, 5. Whoops, I made it 3 to the power of 0. Just a little bit of trivia. Anything to the power of 0 is 1. I know I have said that before, so if we printed out X here, we would see 1. Just like that. So what if you wanted to add all the values in that array together? We have 7 numbers. We might want to add them together. Here's how you would not do it. So don't even type this. I'm going to erase it pretty soon. Pn subscript 0 plus PA, Pn subscript 1, etc. Right? I'm not going to want to do that over and over, print them all out like that. Instead, I'm going to, what is a long way and then there's a short way. I'm going to show you the long way first because it's a technically correct way, but then there's always cool shortcuts. What I would need to do is to declare my accumulator variable, the one that's going to hold the total, and then I could use a for loop for every value in the phone number array for v in pn colon, add that to the total. Total equals total plus v. Or I could have just said total plus equals v. Both work. And now let's print out our results, right? Print out array equals, end quote, comma, pn, print parentheses, total equals, end quote, comma, total, like that, right? So we'll see the array, its contents, and then we'll see its total. By the way, slow me down if you need. You need me to slow down if you're typing along, which of course is not mandatory.
I do have a question.
Sure.
All of a sudden I just got lost. The purpose of arrays. I don't understand the purpose of the array.
It's just like a list, right? You go shopping, you have a list of groceries. You look at your phone, you have a list of phone numbers. You look at your MP3 player, you have a list of MP3s. Okay. You look at a series of mailboxes. Each mailbox, is for a different house. You have, that's all an array is a list. And so anywhere in the real world that lists are applicable, then arrays do the same thing.
Okay, so when you do the for loop, then when you would flow chart it, then each is it variable, then has a certain function?
Well, we're not talking about flowcharts. Each element in the array has a value, just like this. Here was our phone number array.
Uh-huh.
That's an element, that's an element, that's an element, just like you had several people standing in line. You could have, you know, Bob standing in line, who's in front of Fred, who's in front of Carol, like that. So now we have three
Okay.
people in that array, three people in that list.
Okay. So it's gonna, I guess I shouldn't, the flow chart's probably not a good example. I guess what I'm trying to say is that when it processes in the loop, it's gonna process for Bob and then for Fred and then for Carol, right?
Exactly. If I print it
Okay.
out like that for every V in that line, print V, it's going to print out Bob, Fred, and Carol.
Okay. Okay.
And
Thank
there's another way that I could do it too. Not that I want to confuse you, but there's another style of for loop that would be able to do that as well. And since these things can be accessed by their number, for example, you could just print, you know, the person. Oh, come on. I wish I could disable my keyboard's touchpad. Print, you know, the person standing in position 0, and you could do that for position 1 and 2. If you get the idea of that,
Okay.
right? If you see that, you know, all that's changing is that number there,
Oh, I
you
see.
could
Okay.
use a loop to do that, right?
Okay.
You could do something like this for I in range. We have talked about for loops, right? Tell me this isn't
I,
new. If it is, it's okay. But have
Yeah,
we been
we've
using
talked
range
about it.
statements?
yeah.
Okay, good. All right. So for I in range 3, I don't know why I was typing 4 there. Then print out the person standing in that specific place. So this is going to count from 0 to 0, 1, and 2, right? I is going to go 0, 1, and 2, just like we would see here.
Okay. Okay.
So that works just like that. Whichever way you would be happier printing it is fine. I'm always going to go for this one. It's a little bit simpler syntax.
Uh-huh. Uh-huh.
One thing to note here is that if our array was suddenly longer, right, if we added several more people to the line, then this 3 would no longer be a good value. And so instead, we should ask the array how long it is. And how do you do that? You do that with the length function. What if I did something like this? Number of people equals len parentheses line. And there goes my touchpad again. There we go. And then I would say for I in the range of the number of people. And that way, if there were 4 people in the array or 5 or 6 people in the array, since this is returning the length of that array,
Mm-hmm.
then this would count up to the appropriate number. So if we went and added one more person to it, Donnie, this would no longer work, right?
Right.
This would not get them all because this gets just
I see.
0, 1, and 2, doesn't
Uh-huh.
get 3. However, num people is equal to line. Since this array is 4 elements long, num people is going to be 4. And so when we count from that range, it's going to count 0, 1, 2, and 3, or whatever the maximum value is, right, of the people if we go and add
You're
some
not,
more or whatever.
but you're not limited at that point then however many people are in the line. You're not
Exactly. Right.
Okay.
Right. So this handles the fact that the array could be 1 element long or it could be 1,000,000 long. But
Okay.
honestly, I would just do that.
Okay.
But I'm trying to show the connection between
Right.
processing a loop and just doing a series of commands on each particular value.
Right.
Right.
Okay.
We can see the connection between those two.
Okay. Well, that helps. Okay. Thank you.
Sure. So the subscript or the index is the position number of the array, right? The first person is position 0. The second person is position 1, and so on. When you put data into the array, they call it populating the array. I guess we have to have a fancy word for that. So the size of the array is its length. The size of this array is 3. So if we did X is equal to LEN CA, it's going to equal 3. There are 3 elements in that array. I think I'm going to scroll back up to the top where I've been putting some good, useful comments and putting placing values in an array is called populating the array. The size length of the array is the number of elements in the array. So how arrays occupy computer memory? When the variable is declared, it's at some place in computer memory, and you don't really have any control over that. But like if you do A is equal to 3, then some particular series of bytes in your computer is going to have to be set to 3. And so every time you change the value of A, it's going to go to that specific slot in memory and change that number. Well, the array is a sequence of values rather than just one. So if we put 3 numbers into our array, price is subscript 0, price is subscript 1, price is subscript 2, they would occupy 3 places in a row in the memory. So an array, Joni, one question you asked a couple of days ago was, when would you address things by their memory address rather than by their name?
Mm-hmm.
And I didn't think of it at the time, but an array is an example of doing that. It's doing both in a way, right?
Mm-hmm.
Because we have this line here, and then if we want to print out that person right there, then we know that they are at position 0, 1, and 2. We are in effect doing it both by the variable name and its address. It's just not a pure memory address. It's an address that's tied to a specific list, to a specific array.
Okay.
So characteristics. We've got to get all fancy and use the term contiguous. Contiguous means just one after the other. Dump, 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 like that. An array is a list of data items in contiguous memory locations. Every data item is called the element. Each array element is of the same data type. Each element is differentiated from the others by its subscript, also known as its index, which is a whole number. In a way, that kind of makes sense because only in Harry Potter world do you have, like, train station number 3 and 7/8 or whatever, right? And everywhere else, you either have apartment 1 or you have apartment 2 and you have apartment 3. You can't have apartment 2.7, at least in any apartment complex I've ever lived in. So the subscript, the number inside the braces, does have to be a whole number, right? But it could also be a variable, right? If I set X equal to 5, then I could access, list element number X. So back up here where I printed out Carol, I could have said this: I, just short for index, is equal to 2. And then I could do print line subscript I. And again, it's going to print Carol when I do that. So the 2 is the subscript, also known as the index. And I'm sorry, gang, I try to avoid using I's like that because it looks like a 1. I could have used the whole word index and then it wouldn't look like a 1. Lowercase l's are worse though, right? Because they absolutely look like 1s.
We can you'll put this on the canvas so we can print it, because I'm watching and I'm not getting it typed.
Oh, sure, sure. Absolutely. I'm not expecting people to type.
Oh, okay.
I mean, like if you had two screens in front of you and you had all the time in the world, great. But nah,
Right.
I always upload the notes.
Okay. Great.
So the usable subscripts are 0 to 1 less than number of elements in the array. Or if I wanted to pretend I was a math major, I could say the index ranges from 0 to n minus 1, where n was the length of the array. Right? Okay, that sounds real mathy. But why am I focusing in on that n minus 1? Or why do they focus on 1 less than the number of elements? It's because if we go back and look here, we have 4 people in our array. This is index 0. This is index or subscript 1. That's index or subscript 2. And that's index or subscript 3, right? So the length of the array is 4. And so the values of the subscripts can be 0 through 3. The subscripts index go from 0 to 1 less than the length of the array. Just because computers start counting at 0, right? If they started counting at 1, that would be 1, 2, 3, and 4, and then the length would exactly match the highest subscript. If you try to access an element of the array that isn't there, if you get the subscript wrong, it'll crash. So for example, we said that we can have elements, subscripts 0, 1, 2, and 3, but what if we change this to a 4? There is no fourth element, right? It's past the end of the list. It's past the end of the array. So when it tries to print out that element, when it tries to print out element 4, it's going to fail, crash the program. List index out of range. If the subscript I don't know how to say this in a is out of bounds, it is greater than or equal to the length of the array, the program will crash. So you just don't want to do that, right? How many elements do we have here? We have 7 elements since it's a phone number. And so that means that we had better not access element index 7, 8, or 9. You know, we can use element 0, element 1, element 2, element 3, element 4, element 5, element 6. But a 7 would cause it to crash, or an 8 would cause it to crash, or a 9. It's just like referencing if you have a 100-room apartment complex and then you try to send the movers to apartment number 200. Not going to work. There were only 100 apartments there. So to get the size of the array, you use the len function. To get the sum of the array, you could write a for loop like we just did here, or you could just cheat and use the sum function. So for example, if we wanted to add up all the values in that phone number, we could do that. We could say total was equal to the sum of Pn, which adds every element of the array. And whatever 8 plus 6 plus 7 plus 5 plus 3 plus 0 plus 9, there it is.
But that's only when it's integers, right?
Exactly. If you try, oh, that is such a good point. It's when it's numeric data, integers or floats. But if it was strings, that would cause it to crash. So we could not call the sum of line, but we can call the sum of that one. Very good point. If the array contains integers or floats.
How does it work with floats?
Same exact way. Nothing
I mean, how do you
changes.
type floats in? I mean, just whatever point, whatever.
Right, right. So if we're going to make a different array, P and 2, whatever, like phone numbers really have floating points? No, but 8.1, comma,
Okay.
5.2, comma, 6.6. Yeah, I'm going to call this AF, or an array of floats.
Okay.
And this was, of course, an array of strings. Excuse me. So the index goes from 0 to n minus 1, where n is the length of the array. Each array element can be used in the same way as a single item of the same data type. That is such a weird statement, but if we had these two numbers in an array, and we had something that needed to be integers, right? We could do total is equal to nums subscript 0 plus num subscript 1, right? And then that gets treated like it's the number 2, and that gets treated like it's the number 3. So each piece of the array is just a piece of data that can be just used just like any other variable of that type.
Does the same principle apply in other languages?
Yes. Yes. I'm totally skipping this one. I think they just needed something to talk about to make this chapter longer. And this is a very spurious example that goes on and on and on. So using constants with an array, you could hold the size of an array in a constant. That's so sorry, excuse me. Or as array values or as subscripts. Now this is very, 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 very common. Quite often you'll see people do something like that. They will say, I'm going to make a constant, which is the, number of fruit is 3. And then they might create the array of fruit. Like that. And then they refer, whenever they need to, like if you were going to use a for loop to print it out, they can use that variable. For I in range, num underscore fruit, print fruit subscript I, like that. That would print it out. Again, I like the other for loop, the value-based for loop, better. For every value in the fruit array, print that value out. These both do the exact same thing. I'm awfully fond of that one. Looks so much cleaner, right? But anyways, storing the length of the array in a constant is something that a lot of people do, and in some languages, it's just about mandatory. It's not mandatory in Python because you can always ask the array how long it is with that len function, right? So instead of saying num fruit there, we could have put len parentheses fruit, and it would have worked just as well.
I have a question. How can that be 3 if you have 0, 1, 2, 3 for the?
I have 0, 1, and 2. The indexes of an array can be from 0 up to 1 minus the length of the array.
Okay.
Is the question about how this is going to work, the range statement?
No, I was thinking you have 0, 1, and 2 places, and then we have num fruit equals 3. I was thinking.
Okay,
I realized
that's a difference between the size of the array and the maximum value of the index.
Okay.
If you wanted to say the maximum index is equal to 2, that is correct.
I see.
Right?
Okay.
And then the minimum index is 0.
Okay.
if we had an array that had only one value, our veggies basket was pretty slim and all we had were green beans. In this case, the number of veggies is 1 and its max index is 0, right?
Right.
Because
I
all we
see.
have that. Yeah.
Okay, great.
And that works out well for the range statement, because if you remember the range statement, if you have for x in range 10, that actually counts 0 to 9. It goes up and it stops when it hits 10.
Right.
So
Okay.
when we use num_fruit as 3, it's going to count 0, 1, and 2.
Okay. Okay.
Very, very good question.
Did you mean to put the 2 ends on that for loop?
Let me go look.
First one, for and n range.
No, thanks.
Oh,
That's
I
an
saw
I.
that one go. I forgot
Yep,
it.
yep.
Yeah. Yeah.
Thank you very much.
Good deal.
So using an array constant as the size of an array. Avoid magic numbers, unnamed constants. What does that mean? Well, if I'm way down here in the bottom of my code and I say, for x in range 5, and then I do something with it, you don't know what that 5 is referring to. It'd be better to store that in a variable like I did up here so that we actually know what it's referring to. That's just the same thing that we were talking about when we first came across the idea of constants, is rather than use values that are so-called magical numbers, numbers that the reader of the program might not know where it comes from, it's good to give those numbers names so that they do start to make sense, like the number of fruit. Declare a named numeric constant to be used every time the array is accessed. Well, since we have the len function in Python, these rules are not so important, because I could always, rather than create not that it's wrong to do it that way, and if you think the code is easier to read by having done it like this, I'm going to get rid of this max index one. We've got the idea now, I think.
Mhm.
Same with that one. But I did not have to use this constant here in order to step through it. I could have just done for I in range parentheses, len parentheses, fruit, close parentheses, colon, and then print the fruit out at that specific index. Right. Now, maybe that's harder to read than this. I would tend to always want to do this, though. If the language lets me, and it does, I would rather always do it than like this. Why? Because what if we appended something to the array, right? What if we went and added something to the fruit, which is not strictly possible in a lot of languages, but it is true in Python. If we do fruit.append, and I like kiwi fruit, there we go, right? All of a sudden, this variable is no longer valid, right?
Mhm.
It's now got 4 pieces of fruit in it rather than 3. So if I had my druthers, and in Python we do, I would always prefer to do it like that. However, I could just store that in a variable before I used it. If I don't like the way that looks, I could have done it that way, or I could do it like this. Num_fruit equals the length of that array. And then for I in range, num_fruit, print the fruit at that specific position. Now that's totally legit. That's a perfectly good way of doing it.
But the other way, if you change your fruit, all you do to an append statement, and it takes care of it without changing the num_fruit equals 3.
Right. So if we do it this way, and we did that at the top of every for loop,
Mm-hmm.
then that handles the case that the array may no longer be 3 in length. Exactly. And so does this one.
Yeah.
This
Okay.
is a bad idea if we just use this number without ever worrying that it's correct.
Mm-hmm.
So here we have created that number and then use it, but even better is that way. The
Yeah.
books doesn't talk about this syntax because it's not valid in a lot of languages. But it's valid in Python, and it's valid in Java, and in something called C#. It's good syntax. It's just not available in a lot of languages. And so the book tends, I mean, the book really
So
can't talk about things that don't apply to most languages.
what did
And
we use?
this
So
way
what
of
did,
doing it is so nice and so convenient that although I keep giving you examples that look like that, I cringe while doing it because I'm sitting here knowing that I can do that.
so the V stood for what?
Value.
Value. Okay.
Or I could have said for the element, right? Because we also call them elements, but I like V for value.
Okay. Okay.
And there's nothing wrong with typing the whole word out.
Could you put a notation next to that's probably the simplest manner for us in Python?
Yeah, sure.
Just so, because we go back and look at the notes, it doesn't get confusing.
You can use range-based loops to access arrays, like in a lot of examples here, but the value-based loop is way easier to type.
Thank you.
Yeah. I think I'll cut that and paste that so that it's below the comment.
Okay.
Whoops, where'd that come from? All right, guess I wanted to go to the PowerPoint anyways. Sometimes the values stored in arrays should be constants. Okay, they're just saying that every string is a constant. I guess I might agree with that. Searching an array for an exact match. What if I know that somebody named Bob Roberts lives in the apartment complex? Well, I would go to the apartment complex. I would knock on door number 1 and ask them, or, the first door number 0 in computers, right? And then I would knock on the second door and ask them. Then I would ask them, the third one, the fourth one, the fifth one, and I might eventually find them. This is the one case where a range statement is actually the way you have to do it rather than a value-based for loop. So let's say that we have not sure what that was. I'm going to delete that. So we have our people list. And we have Abe in there, and we have Bob in there, and we have Carol, and we have Doug. And we want to do something with the Doug piece of data. I'm not sure what. I'm not sure if we're going to replace it with something else or, whatever, whether we're just validating that they're in the list or something like that. You have to search it element by element. And to do that, you would need a range-based for loop so that you have the index number. If you do it this way, you don't have an index number. So let's say that the person we're looking for is Carol. So number of people is equal to the length of the people list. And then for I in range num underscore people, if the person at that specific position is equal to our target, then great, we found them We found them. We do something, whatever we needed to do with that. Print, we found, in parentheses, target, or not in parentheses, in quotes, at index, end quote, I. And we might want to save the value of that index for purposes later on, right? If we get down here and we have never found the person, then that is probably also useful information. So we might want to store some value I don't want to fluff up this example too much. I kind of like the way that one looks just like that. So I'm not going to clutter it with other things. I'm going to leave that alone. This is an example of searching an array. This is also called a linear search. You know what linear means? It means in a line. Why is it a line? Because we start at the first value, we start at the second, we go to the third, we go to the fourth, and we keep doing that. Ooh, look at that. List index out of range. I wonder what I did wrong. Line number 26. All right, I'm at line number 26. Oh. Well, that's true. Did I do this on purpose? I don't remember. Maybe I said that it was going to crash it and then I never actually ran it. Here's our array. It's got index values 0, 1, 2, and 3. So if I set index equal to 4 and try to print it out, that will crash. I
You
don't
did it
remember.
intentionally a while ago.
Yeah, okay. I never changed it back. That
Yeah.
amuses me. All right, let's run it again. And so we found Carol at index position 2. Guess we could have printed the array out beforehand just to kind of see it, right? But that is the case. So a linear search is a for loop, a range-based for loop, where you step through item by item, value by value, element by element, looking for your target value. So you can have a flag, which is a variable that indicates whether an event occurred. We could put a variable in here that indicates whether the variable was found or not. And like I said, this was such a good example that I don't want to clutter it, but now we're going to go ahead and expand it. So I am going to copy and paste it. And I'm going to make a variable called found equals false. And if we ever do find it, we're going to set found equal to true. And this index value here, we had better store that so that we could refer to it later. So I'm going to make a variable called found index, and I'm going to set it equal to -1 just to indicate that we never found it. But if we get here, then we're going to set our found index equal to our current index, right? And I'm going to cut that line and paste it down here. But I'm going to change it so that it says if found, colon, print, we found the index at index found index, else print parentheses, we never found, end quote, comma, target, right? So here we are marking set flag to show that we found it, and record what index we found it at. So maybe you can see why I like this example, right? I think that illustrates the concept in its most fundamental form. And then this is wordier, but it's more useful, right? I mean, we didn't just add things to it to be adding things to it. How is it more useful? We know whether we found it or not. Do y'all keep seeing the little connected, mouse connected Message in the middle. Okay, I'm sorry about that. I don't know if I need to replace a battery or what.
It's okay.
Alrighty. And so not only do we keep track of the information that we found it or not, but we keep track of the which position we found it at so that later on we could do something. Like what if Carol is changing her name to something else? So if found, we're going to change the value at that position from Carol to Connie.
I got a little lost on that statement right there.
This particular one?
Yeah, the last one you typed, the people
Right.
found index.
Right.
Where
We have the index number of that position here.
Uh-huh.
And so if we find it, let's change Carol's name to Connie. That's what's going on here.
Oh,
If we
okay.
found it, we're going to change the value at that position to our new value.
And it'll just automatically change it then.
Yeah, and so then if we print it out, we're going to see that it's a Bob, Connie, and Doug. Oh, that's getting annoying. All right. Right, and so we did find Carol at index 2, and then we changed the value of Carol to Connie doing that.
Okay.
Does that make sense?
Well, I know where I'm kind of lost all of a sudden. Is how did we? Is it back up where it says if people I? Where did we define Carol as I?
We didn't. We said that our target was Carol, and that's what we.
Oh, okay. I'm sorry. That answered my question. Thank you. I just got confused.
Let me turn the mouse off. All righty. Okay, so right, that's the target that we're looking for right there.
We defined it there. Okay.
Correct. Now, predictably, there's a Python command that would do all of this from about here to here with a single function call, right? So that we would not have to write that loop. Hey, I turned you off. There, turn Bluetooth off. Okay, so you can do the same thing with a single line of Python, and I actually don't remember what it is. Find index of element in list in Python. I think it's just called index. Okay. So if we wanted to do the same thing, we could have just done this. Found index equals people.index, and please search for Carol. Except Carol no longer exists, so I better be searching for somebody else. Right. That does the same thing. Sure is nice to be able to do that. I did want to show you this idea so you knew what was happening behind the scenes, even in a function like that. It's just starting at the beginning and is going to the end. Let's print out what found index is and see. So the index of Abe is 0, and that's correct because Abe was the first element in the list. What if we look for somebody who doesn't even exist? Eric. Nope, we only have A, B, C, D. We don't have any Erics. And there we go, right? The index of Eric is 0. No, it's not. Oh, I never changed it, right? I said that I was looking for index, but I never did. Really, I should have done it like this. Right, and then I would be looking for my target, and then I would say the index of, end quote, comma, target, comma, is, end quote. Okay, so to make sure that it works, I'm going to look for Bob first, prove that it does work, and then see what it does when it doesn't. All right, so the index of Bob is in fact 1. That's correct. It's because that's 0 and that's 1. Now let's change this to somebody who doesn't exist in the list. Eric is not in the list. That's a drawback to using that kind of function, right? Because what does Python do? In this particular case, and I kind of disagree with their reasoning here, they just throw an error if it's in there or not. So how do you fix that? You do this, and this makes it look kind of ugly, so that the advantage of having all this in the nice short syntax, if target in people, colon, then do that. This keyword in does a search. Just like you could, you know, if you have the name is equal to Sammy, and then you could do if y in name, print, yes, there is a y. Or you could do nums equals, I'm just typing numbers in at random. And then if 9 in nums, print, yes, there is a y, excuse me, yes, there is a 9, else print, no, there is no 9. So this is how you check to see if something is an array in a single statement, the in keyword. That index, that keyword lets you check to see if something is in an array. And you would replace value with the actual thing you're searching for and array with your array name. Example, can I type? If red in colors, right? Assuming we had an array called colors, we could search the array to see if the color red was in it. All right, so far, these have all been single words, but we could put multiple words in there if we wanted to. I'd have to be careful because we are deliberately searching for specific things. So I don't want to change Carol, but we could have done like, this is going to be, you know, Abe Abrams. And this is going to be, you know, Bobby Bullitt. This is going to be Carol Channing. And I said I wasn't going to change Carol, but I did anyway, so I better change that, right? And then Doug Dirkley. So you can use, you know, the data can be anything, single words, double words, whatever.
I have another question.
Uh-huh.
In the print statements, where the comma And then you have like target and comma, found index.
Right here, that one?
Yes. And so print statements, I think, have confused me a little bit along because I don't know how understand. So you're telling it to print the we found, and then when you put the comma target, it refers back to the target and pulls that information.
Right. And what was the target? It was Carol Channing.
Carol Channing. And
so
then
it's going to print we found
and it goes up and pulls target.
Carol
Okay.
Channing at index, and then whatever that variable got set to inside here.
Okay. So your print statements could get pretty long then in other functions.
Absolutely. Absolutely.
Okay.
So if you have a Python shell and we say x is equal to 3, where did Connie come from? And then we have y is equal to 6. We could do print, x equals end quote, comma, x, comma, and I want end quote, comma, y, comma, quote, pieces of pizza. Now, I sure hope I didn't make a mistake in this because that was a lot of typing, but there, right? X equals 3, and I want 6 pieces of pizza.
So you just put the comma and where you want it to draw the info from, and comma, and then move on then.
Exactly.
Okay.
All right,
Great.
so what are we going to do here? We are going to assign as homework, write a program that creates an array that is a list of your 4 favorite books or movies or restaurants. Wouldn't that be nice to go out to restaurants nowadays? Or, characters, fictional characters, or real people, right? Whatever, like that. So write a program that creates an array that is a list of your 4 favorite books or movies or restaurants or heroes, just like we've done, Here we have a list of people so that you could do that. And then write a value-based for loop that for VN syntax to print the values in the array. And then write a range-based for loop, which is where you do like for I in range to print the values in the array. So this might be really, really short for you. If it's not, that's okay. Text me and ask me for help, or, we can even zoom in together so that I can see your screen and you can see mine. I'm getting kind of fond of this Zoom business. I didn't think I would be happy with it.
So you're able to see you have a way to see our Zoom screens as well?
You have an option to share your screen with me.
Okay, good deal.
It's not enabled by default. I can't see you and I can't see your screen, but if you go fishing around in your options, you can find the option that'll start sharing it with me.
Okay, so if we have a problem with the program, then you can see what we're doing. So
exactly.
Okay, great. All right.
All right, gang. I think we're done. Let's go ahead and make a Dropbox for it. And if you want to hang out and talk more, we don't have to stop right at this point in time because nobody has the office after me, har har. But, you probably have other things to do. But I want to go ahead and get the Dropbox made. Did we say this was Lecture P? It looks that way to me.
Yeah, Lecture P. Yeah.
Temporarily, I'm going to stick it in the week 11 box. And then move it to a week 12.
What do you want us to drop? Just what we do have, or just a note,
or even a note just saying I watched it, right?
Okay.
You can type in a little text comment. That's enough. I'm not making people fill out lecture review forms or whatever, but if you did type any notes, you may as well upload them.
Okay.
Did you make a video for Monday whenever we didn't make a class?
Actually, I did not. So there's nothing you have to catch up on.
All right.
And you're right, I should have. So I kind of failed on that respect. Let's go ahead and publish it.
It's okay. I've got so much to comprehend right now. Thanks.
I thought I had linked a video that I wanted you to watch. It's just about 15 minutes long. I'm not sure that I okay. I am going to have some videos that I do want y'all to watch.
Okay.
They're optional, but I'd appreciate if you did watch them. So I will post them later. I'll make
Okay,
some
great.
links directly to them. Very short ones, and I think you'll find them educational.
Okay,
That's
Are you
great.
the point.
Are you just gonna email it to everyone?
I will post it here.
Okay.
Yeah.
Just on this page where you like week
It'll be
11?
in week
Yeah.
12 as soon as I move this to week 12.
Okay.
And I'll post an announcement to that effect.
Okay, great. Will it have to do with like arrays and things, or it's just
Not
other-
specifically.
Okay.
It's just about, it's called Crash Course in Computer Science. And
Oh,
so
okay.
basically it's going to brush up on things that we already talked about in the past. And it's okay if your eyes glaze over and you don't like what you're watching, but on the other hand, you may get a lot from it.
Okay. I think it's great. It's great. I find sometimes when we go over things that glaze us over at the moment, then later they kind of soak in a little better.
Yeah, that's why I like to have us, see things multiple times. I like to type it in and then show it to you on the PowerPoint, and then look at it again, and then mention it again the next week. So, by the third or fourth mention, it's nailed down firmly in the brain. Whereas, if you were just skipping through the PowerPoint, it probably wouldn't sink in.
Right, right.
All right, gang, I will see y'all Monday, and I'll go and grab the links for the videos that I want you to watch and stick them in the week 12 folder right now.
Okay, great. Thanks a lot. Thanks
Oh,
for
sure
all the
thing.
explanation.
All right, see y'all Monday.
Okay, see you
Monday.
later.
Thanks. Bye.